Hey coding birds. So basically in today's LeetCode problem today, here we have a problem 3005 which is count element with maximum frequencies, and it is an easy problem. And as the problem statement is given as, you are given an array nums consisting of positive integers. Return the total frequencies of the element in nums such that those elements all have the maximum frequencies. The frequencies of an element is number of occurrence of the element in the array. So here we have an example, and basically in the given problem, here we have an array, okay, and inside array it contains like duplicate also, okay, duplicate value also, and here we have to return the count of the maximum element with having maximum here to count the elements with having maximum frequencies. Like if I'm talking about the first example here, so here we can say that 1 is occurring for 2 times, so here the frequencies of 1 is like 2, and for 2 is also 2, 3 is like 1, and 4 is also having 1 frequencies only. So here explanation is given as the element 1 and 2 have the frequencies of 2, which is the maximum frequencies in the array. So the number of elements in the array with maximum frequency is like 4. What is the approach to solve the given problem is here. Here we have just check which is having the maximum frequencies. So here 1 and 2 is having the maximum frequencies. So we have just simply added their maximum frequency. That means 2. So 2 plus 2, which is like 4. So here we are actually getting the frequencies of 4. So here we can simply say that here the array, the number of elements in an array with maximum frequency is like 4. Okay, similarly if I'm talking about the second example here, so here we have 1 2 3 4 5, and every element inside an array here is like having the frequencies of 1, which is maximum element. Okay, so if the number of, so here we can say that the maximum frequency is 5 here. Okay, constant is given where it is written as nums of length must be like greater than equal to 1 and less than or equal to 100, and nums of I must be greater than equal to 1 and less than equal to 100. And this is like completely based on an array has map counting and weekly contest 380. Here I have also like watched about like hint, like here what we have to do, how we have to solve this problem. So here to just simply first of all count the frequencies of the element inside the array, and then once we have like count the frequencies of the array, we have to find the elements that have the maximum frequencies, okay, and then count the total occurrences. Okay, so let's try to solve this problem here. So as here first of all what we have to do in our first step, first we have to count the frequencies of each element. Okay, so how we can do this thing which here this thing can be undone by using unordered map. Okay, so here we can simply use map for getting the frequencies of each element, okay, where it is having integer type. Okay, and we have to also count the frequencies in integer type. So here we just simply define map as mp, and now we have to traverse inside the array and count their frequencies for each element. Okay, so here we can say that for int let's say I'm saying that I, which is traversing inside the array, which is our nums. Okay, and while traversing here I have to count the frequencies of each element. So you can just simply say that mp of I, then plus plus. This is basically counting the frequencies. After just performing this step, we are actually getting the frequencies of the each elements. Like here I have like drawn the example here. So this image we actually getting. So here I've created the unordered map. That means one is having 2 frequencies, 2 is having 2 frequencies, 3 is having 1 frequency, and 4 is having 1 frequency. So after just performing this particular step, we are actually getting this form of map, okay, where it defines the element of like the elements 1, which is having 2 frequency, 2 is having 2 frequencies, 3 is having 1 frequency, and 4 is having 1 frequencies. So now in our second step here we have to count. Here we have to check for the maximum element, okay, or maximum frequencies. So how we can get these things? Again we have to perform the same thing. Here we have to let's say define int maximum element. Okay, max element here we have to just simply define as 0. Okay, or we can just simply say that maximum element. So here int max is equal to 0, and now we have to again traverse inside the here in this time we have to traverse inside the map, and we have to check about the maximum frequencies for each of the element. Okay, so for let's say for int z, which is traversing inside map here, and then after that here what we will do, here we have to store our maximum frequencies element inside the maximum variable, which is maxi is equal to max of MAXI. Okay, and we have to take the frequencies for each element. So here for how we can get the frequencies, by simply using jet dot second. Okay, that means it will focusing on the second element of the maps. Okay, like here like created this map, and here in this side we actually getting the element, and in this side we actually getting the frequencies. So here what we'll do, here according to this step we are going to count which is having the maximum. Okay, so by watching it also we can say that 2 is having the, like 1 is having the frequencies of 2, and also 2 is having the frequencies of 2, and 2 is the highest frequencies. Okay, so here the maximum value which I will be getting is like 2. Okay, so after just performing this step we are actually getting 2. Okay, so now we have to do what, step 3. In step 3, as the last thing is like given here, here we have to return, okay, return the total frequencies of element in the nums such that those elements all have the maximum frequencies. And we know how many of the elements is having maximum frequencies. 1 is having the maximum frequencies, as well as 2 is having the maximum frequencies. Okay, so here what we will do, here we need to return the total frequencies of element in nums here, as it is written that such that those elements all have maximum frequencies. Okay, so let's try to do these things. What we have to do here, again we have to make a, let's say, int count, because we have to like return the counting variable. So int count is equal to 0, and then again we have to traverse for int I is equal to, not I, for int z, again I'm actually declaring it, and again I'm traversing inside the map. But this time what I have to do here, I have to count, right? So here we have to give the condition, if our maximum value, maxi value, which is currently 2, if 2 is equal to we can say that z dot second value. Okay, then here we have to just simply make what, here to simply do count plus plus. Okay, and at the last we have to simply return our count. Okay, but the thing is that here we have to do this thing, count plus equal to, because in the first iterations we actually getting count as 0, and we have to add it with z dot second. Okay, so in our first iterations we are actually getting as 2, and we have to check for other also elements. So for for element 1 we are actually getting 2, and for 2 also we are actually getting 2, like here as I have explained here, like for the element 1 we are actually getting 2, and it's also satisfying the condition like our maxi should be like equal to z dot second element. Okay, so it is like 2, so it is a maximum element. So here in this time, here at the first iterations we are actually getting result which is 0 plus 2, which is 2. In the second iterations we again check, so 2 is also having the same number of frequencies, so again result plus 2 is equal to 4. So as our final output is also 4, so we have to return 4. Okay, so yeah, that's all about this problem. Let's try to um, compile and run this problem. Okay, auto shed. All right, let's try to compile and run again. Okay, I will not use this thing, semicolon. Okay, let's try to compile and run again. Okay, again. Okay, auto of z, which is traversing inside the map, and maxi. If maxi is equal to z dot second, then we have to do this operation. Okay, so yeah, your comparison is done. Let's try to submit it. So yeah, it's submitted. So yeah, that's all for today. Thanks for watching.